to help her collect samples. That is much more practical, Grace.
That is very practical. How about the rest of you? I can see many of you joining us now. If you could bring an animal with you to Mars or to the moon, you're going someplace for a long time. What would you bring with you?
To help her collect samples. That is much.
Something to help you collect samples. So a gopher to help you collect samples. How about the rest of you? Please feel free to enter things in the chat. What would you bring with you to the moon or to Mars? Let's go ahead and get started. Welcome everyone. We're glad to have all of you with us here today. And thank you so much for joining us as we're beginning our next Sharing Planetary Science session. So this one is all about engaging children. This session is being recorded and it's being live streamed right now on YouTube. And we're delighted to have all of you with us. We've got some information for you. We've got questions for you, and we're going to be asking you to participate. You can enter things in the chat. You can enter things in polls, but please, there's opportunities for you to raise your hand or do other expressions as well. Please join us and participate. And my first question for everybody here. So Vivian, this is one of your questions, and Sha'Rell's seen this one before as well, but I'd like all of you, please, to enter in the chat. How are you feeling today? Which one of these are you today? Are you feeling insightful, perhaps like a radio telescope? Are you feeling thoughtful, perhaps like an optical telescope? Maybe you're feeling adventurous like a spacecraft, or adaptable and spontaneous like binoculars. Please enter into the chat now how you are feeling today. Let us know a little bit more about how you're doing today. And Kate says, always a spacecraft. Adventurous. Thank you so much, Elise. How about everybody else? Marian says optical, and Mike says adaptable. Jordan says thoughtful. Bill, concerned about the success of the Webb telescope. Okay, there we go. Amber says optical, feeling thoughtful. And while you are all doing that, Maria says she's feeling adaptable. Wanted to know just a little bit more about who you are as well. So I'm going to launch a poll as well. Please, how would you describe yourself? Carlos, thank you so much for joining us from Mexico. Great. How would you all describe yourself? Everybody that's here with us right now, would you describe yourself as an experienced planetary scientist? As an early career planetary scientist, as a college student? Do you teach planetary science, maybe at a university or at a school? Are you an engineer? Are you an educator, somebody involved in public engagement? Are you a scientist, but not necessarily a planetary scientist? So we're going to give everybody about 10 more seconds to finish answering this poll. And while you're doing that, let's go ahead and start who we are as well. 5, 4, 3, 2, 1. Who all is with us? We've got a variety of people here. We've got planetary scientists, we've got college students, we've got people who teach planetary science, we have educators, and we have scientists in general. So one of our speakers today that we're honored to have with us is Vivian White. Vivian, please go ahead and say a few words about yourself.
Hi there, I'm Vivian White. I work at the Astronomical Society of the Pacific in San Francisco, California. And I get the huge pleasure of working with amateur astronomers with the Night Sky Network. And let's see, I am a hobby potter. I'm a mom to a 10-year-old who keeps me on my toes. Oh, I brought, this is my latest mug that I just made that I'm super excited about. And I was showing Sha'Rell earlier, I am today making an axolotl costume for Halloween. Some of what I do with my time. Thanks for having me, Christine and Sha'Rell.
Thank you so much. Sha'Rell is our public engagement lead at the Lunar and Planetary Institute. Sha'Rell, please say a few words about yourself.
Absolutely. Well, hello, and thank you all for just taking some time out to join us today, talking about engaging audiences. My name is Sha'Rell Webb, and I am the Public Engagement Lead at the Lunar and Planetary Institute. But before coming, I was an educator inside the classroom for 8 years, high school chemistry, 7th grade math, 8th grade science. But by far, my favorite was 8th grade science. And so I'm so happy to be here to just share with you some of the tips that I have.
Thank you, Sha'Rell. And I'm Christine Shupla at the Lunar and Planetary Institute, where I have the honor of being the Education and Public Engagement Manager, working with Sha'Rell and occasionally with Vivian and with people all over the place. So we're delighted to have everybody here with us. I've got one more poll for all of you who are joining us. So we have a little bit more information about who you are. Let's find out a little bit about your experience. Have you done programs for children before? Have you done programs for children here, anywhere up to age, let's say age 12? And we'll give everyone a few more seconds to finish answering. 5, 4, 3, 2, 1. And we've got a mixture here, a mixture of results. So many of you have done programs for children before, but some of you haven't ever, and some of you have done a few times. So that's good to know. Thank you so much. So what our plan is for today, for the seminar, is we're going to share some pointers, and we're going to do some activities with you and sort of assess how we're using and how you might be able to change and modify what we're doing to engage children better. So let's go ahead and let's get started. I'm going to go ahead and move us along. And Vivian, I think this is you.
All right. Welcome everyone to working with young children. So when I'm talking about young, I'm going to be talking about the youngest kind of all 3 to 6 year olds, 4 to 6 year olds. The very young children are absolutely just natural scientists. They are curious about everything. They want to know as much as they possibly can, and they can be really fun to work with. And I was just going to give you a few tips that might help with your engagement. It sounds like a lot of you have done work, but I'm not sure about this age. So just to give you a little bit of background, we at the Astronomical Society of the Pacific had a grant to see what pre-astronomy ideas 3 to 5 year olds could grasp and understand and learn about. And so I worked a little bit with that. And then I've also been working with the Girl Scout Space Science Badges with a big team out of the SETI Institute to come up with space science badges for everybody from brownies to ambassadors. So that starts at 5 years old, engaging the very youngest. And if you go to the next slide, before you go to the next slide, I wanted to say some of the things that we have been doing. I just made a little bit.ly for it. It's bit.ly/astroyoung. You can see some of the activities there that will give you ideas about ways to work with kids this age. But I'll give you some quick tips if you, let's see. The keeping it fun is a big part of it. And I always like to start with a joke. So if you hit next, I'm going to ask, how do you throw a space party? Oh, Kate knows. You have Planet. Go ahead. Well done. Okay, so it's not the newest joke in the book, but for 3 to 5 year olds, it absolutely is hysterical. Be prepared to be silly, be prepared to show enthusiasm and have fun. The next slide will give you some kind of general notes about things that kids like at this age. Definitely you want to keep it moving. You want to keep it creative. A lot of this age has to do with imagining yourself on the moon or on a different planet. Really fun. Also being able to move and talk about the things that are happening through movement. And we'll do a little bit of that later. You'll be prepared to work with the adults that come with the kids. They don't often drop off 5-year-olds in your care, which is lovely because they know their kids best and can be a real help. So definitely engaging the adults as well can be helpful at this age. Online is a little bit harder. You got to realize they're not going to be able to read many of them. So having actions, thumbs up, thumbs down, if they like something, or if you're asking questions in a meeting like this, then having reactions as opposed to typing in the chat is better for this age. All right, what else? Let's see. I love to use fun graphics. If you go to the next slide, the NASA Space Place has a lot of graphics that can teach very simple things like the moon always keeping its face towards the earth, things like that are great for the very young. And to engage little kids, I like to start with a question. So I think there are some planetary scientists here. If you start with a question, this does a couple of things. It engages their existing knowledge and lets them share what they already know. They can learn something from each other, and that's where they learn a lot. Starting at this age and forever on, they're going to be learning from their peers. But it gives them a chance to talk about their interests and tell something. But asking a question is only half of it, right? Then you have to respond to the question. So on the next slide, I'm going to share a few things about ways to respond that are encouraging and that are also that help kind of move the conversation forward. So like in the chat, when Kate knew the answer to planet, actually quite a few people knew the answer to planet for the joke. Calling them out by name is a really lovely way to get them engaged and let them know that you are listening to them and hearing what they say. And often repeating what they say for other kids. Sometimes it can be difficult to hear when there's so much going on. Again, you're going to find lots of things that are wrong, and they're going to have plenty of misconceptions at this age about everything from lunch to stars. So that is completely normal and typical. And there are cool ways to address that without saying you're wrong. And you can say things like, oh yeah, I've heard that other people have thought that before. Interesting. We're going to learn some more about that today. So promise to get back to it with some accurate information. And just let them know that you're always learning as well. So they're learning all the time and you are learning all the time. I wanted to also just mention that I don't know if you noticed in the beginning, when we introduce ourselves with informal outreach, I try to make it a little bit more than just my science background. So I have a background in astronomy. I don't even think I mentioned that in my introduction, but other things to mention in your introduction have to do with kind of what your interests are as a person. So my pottery, my axolotl outfit, for Halloween, these are things that you can talk about. And Christine and Sha'Rell and I were just on a call last week for International Observe the Moon Night, and I heard this done so well. So I think, Christine, if you're able to bring up that video, it's just a minute or so, but I wanted to show you someone who has introduced themselves in such a holistic way. And I was just like, oh, I would like to share that with you all. Two shakes. So this is Marley Colin Robles, and she'll do the rest. Oh, but I think, wait, if you unmute yourself, Christine, we can probably hear it.
Okay, let's.
Talking a little bit about citizen science and observations in clouds. I know clouds are not always our best friends, but we need them. They make our nights warm. And there are other things that maybe you can do when you do have clouds. So a little bit about me. I'm from San Juan, Puerto Rico. That's why my name sounds a little bit different. And yes, I got to go to the Arecibo Observatory before it broke down sadly last year, but that inspired me to study nature. Even though I am an atmospheric scientist, I'm also a backyard astronomer, and that's a picture of me last year looking at the conjunction. And I've had the unique opportunity of being with the moon rocks collected by the Apollo mission. So I'm really excited for International Observe the Moon Night. I play sports as well, and I've met a lot of people playing sports at NASA. That's my NASA volleyball team, and we still play in COVID times. We just look for a space outside, and I love music. So I really enjoyed that piece that we just heard before I started.
Yes, great. So I just loved how she introduced herself so fully. And if there was a kid who played volleyball or loved to drum, that they are instantly connected with her, even though they may not have any idea what she's about to say about clouds. She gave a great presentation, and even amateur astronomers, myself included, who despise clouds, were very excited to hear what she had to say, and partially because she introduced her whole self. I loved that. Okay, so that was just your quick tips for engaging the really young, and we'll get back to some activities for them a little later.
Definitely. Thank you so much, Vivian. So Sha'Rell, you have some tips on engaging a little bit older children.
Yes, I do. And I thank you, Vivian, for that. Introduce yourself as a whole person. You know, if I was in person, I normally say something like, I am 6'2", you know, and you can't tell me any different because that's what I believe about myself, even though I stand at 4'11". So they usually get a kick out of that because I'm usually the shortest, even if I'm an adult and they're children, because I'm a shorty. But I definitely like your tips. So thank you for sharing that. So as we are engaging scholars who are a little bit older, ages from 8 to 10, I definitely think that enthusiasm, Vivian, you mentioned this is too, you know, being online. And so many of these tips are for virtual learning and the virtual engagement. And I think that energy is infectious, right? And so everyone has been in this virtual space for quite some time now, and you automatically know when you have cut off the speaker because they are not keeping your attention. And so that enthusiasm, even though you may not even really like the topic that you're speaking on or have to deliver at the time, but because you're excited about it, your audience is gonna be like, oh my goodness, why is she so excited about this? Let me listen in. So at least capturing their attention for just a time span to get over what you're trying to give. So energy is infectious. And the second bullet point I have is acknowledgement, calling the participants by their name. Yes, Vivian. Yes, Christine. Thank you for your participation. Thank you, Jordan, for your participation. Oh, I love that. May I see that? Could you hold that up to the screen, Jordan? And calling participants out by their name to acknowledge that you see them and they do exist, and whatever they have produced, because that's what you requested, they're actually completing that task. And so acknowledgement and calling participants by their name is my second tip. And using the timer and countdown. Remember, we are engaging children. So for it not to be long and drawn out, you're going to do that countdown as Christine did with our polls, that 5, 4, 3. So it's that sense of urgency that, yes, I want you to get it done in this time frame. So having that countdown, and instead of you verbally doing a countdown, you can also add a timer in the bottom right-hand corner of your screen. That's also a useful tool to use. My fourth bullet point would be providing opportunities for students to speak and engage. Hey, I am in an audience and I want to say something. So allowing them to utilize the chat box. Have you ever been in a virtual program and the only person that you could chat with is the host? Now, that is a tip if you are wanting to make sure that those responses just come straight to you, but you do want to encourage the audience to engage with other people that they are online with. So providing opportunities for students to speak and engage via also external software like Kahoot and Nearpod. It was a very big hit, Nearpod, on our International Observe the Moon with a page graph. She utilized that software tool. And so we welcome those other things being a part of your virtual program. And last but not least, the active component, doing experiments themselves. Around this age, just watching a demonstration is not going to cut it. So my advice would be, if there is something that is safe for your participants to engage in, send them the handouts days before so they can prepare, they can gather all the materials, and then they can actually conduct the experiment right there in the comfort of their own home, of course with supervision, and allow them to have that experience versus just seeing a demonstration. So those are my 5 tips that I have for engaging 8 to 10-year-olds. Thank you so much.
Thank you, Sha'Rell. And there was a great question here from Melanie that I thought I'd let you go ahead and speak with as well. She wanted to know what you do when your enthusiasm starts to wear down, but you still have more stuff to cover. You still have more to say. You still have more questions. You still have more things to do. And this is tough for Sha'Rell because Sha'Rell, I've never seen her enthusiasm wear down, but I wanted to hear what you might say, and Vivian, what you might say as well.
Yeah, so excuse me for the doorbell. Just
These things happen.
yeah. All right. So with the enthusiasm, the thing about your energy, I feel as though that you're going to have to push through. You're going to have to push through, but also you are being refueled by the comments in the chat box, and you're being fueled by the faces. You know, so a lot of times when we are on a virtual program and then you don't see anyone, right? You don't see anyone because you just see their names, then encourage them to show their faces, because you feed off of them as they feed off of you. And I think that when asking for their cameras, that's just a part of the norm from jump. So you're kind of setting the expectation, but I definitely believe that the energy is going to come from your audience. And because you're getting a great visuals or you're seeing the smiles, that's going to fuel you to the end of the program. What do you think, Vivian?
Yeah, I would agree. I think the audience helps a lot. Melanie was followed up a little bit right here and said, how about when the kids wear out and I'm still enthusiastic? And I was like, yeah, that has never happened to me.
Well, I know that the parents probably would be grateful.
Oh yeah. Even having some times during the activity where they can do stuff on their own is lovely. To have some cut and paste time if you have an indoor place where you can do that, or have them draw something. Imagine what the life would look like if they lived in the ocean on a different planet. So giving some time for them to get creative, for you all to kind of take a breath. Definitely. I mean, a lot of the outreach and public engagement that we do is for an entire night as amateur astronomers. So we're out there for 4 or 5, 6 hours in the dark, outside. And definitely there are down times, there's slow times where that happens. So pacing yourself is really important, and allowing them to kind of help supply that enthusiasm with you, Sha'Rell.
And giving the kids an opportunity to, as Sha'Rell said, participate. So that way, if they're doing things that can invigorate themselves as they're making new discoveries for themselves, right? As they are sharing what they know with other people, whether that be with other children or with their parents, but giving them that role to play where they are telling other people what they know, where they are doing things for themselves, where they are making their own decisions in terms of how to revise or create or adjust something. There was a great comment there from Carlos about, when enthusiasm is about to run out, seeing the kids when their bright eyes and their interest can give you energy. Absolutely. And Sha'Rell, I love that. You adding music for their time in between, independent time.
Yeah, so I've added music during like an independent time. So say for instance, if we're doing a virtual craft, well, I've added of course, it was not music with lyrics or words, but just like just the instrumental, and just to kind of keep it upbeat. And one of the things with that, like when the music went off, they knew that it was time for us to kind of come back. So utilizing music could also be energizing.
Awesome. Awesome. Well, we've got some more information for you all, or suggestions, but please keep your comments and your questions coming. We appreciate that. And then we're going to do some activities with you too. So let's go ahead and talk a little bit about the kids. Motivating the kids means thinking about what their goals are. So what are the children's goals? One goal that the children might have is getting your attention. Hey, look at me. Pay attention to me. For some of the kids, not all of the kids, but some of the kids, their goal might be they want your attention. Does anyone want to suggest other goals that the children might have? You are there in their space, whether it be, at a museum or a classroom or a public space, a sidewalk, with your telescope, wherever you are. What might be some of the kids' goals when you are there with them? What do they want to get out of this experience? Anyone have any suggestions besides getting your attention? Hey, look at me. Watch this. They want to have fun. Absolutely, Sha'Rell. The kids, they just want to have fun. It's not just girls. It's everybody. And they might want to learn something. They might be curious. They might want to learn something. Thank you very much, Sean. Absolutely. So they might want to share what they know as well. Kids love to say, I know this. Look at how smart I am. Pay attention to me. They want to tell you what they know. Exactly, Bill. Exactly. So they want to share what they know. They want to do something fun. They want to do something interesting. And so we need to be thinking about how we can address these in any of the programs that we do for kids, right? When we're doing things for kids, we need to make sure that we're thinking about letting them take our attention, letting them share what they know, as Vivian and Sha'Rell both said earlier, letting them share their pre-existing knowledge and keeping it fun and interesting. And so what the kids do know varies greatly. Some of them know the names of the planets. Some of them know a few characteristics, and they might want to tell you what they know about Pluto or what they know about Jupiter or Saturn. But they also have a lot of confused ideas. And so we need to be careful when we are doing activities with them that we don't overwhelm them with a huge amount of knowledge that is completely out of their circuit of experiences, because they're going to have the same misconceptions that adults have. And most adults don't really understand gravity and that planets have gravity. Most adults, a lot of people don't really know where we've been. They think we've been to Mars. They think humans have walked on Mars. They think humans have left the solar system because they see all these confusing things on TV like Star Trek and Star Wars and all these other shows. And they think that aspects of those are real, and they don't know that, no, we haven't really gone farther than the moon, and that we haven't been to the moon in decades. They don't know that yet. They're confused about solar system versus galaxy versus universe. So they might think that there's a black hole next to Jupiter. They just have no idea, because Jupiter and the solar system and the galaxy are all kind of mixed together in their heads often. They don't know the difference between rocks and minerals. So going into great details about plagioclase feldspar is going to mean absolutely nothing to them. They don't understand what the definition of an atmosphere is. Some people might assume it automatically means breathable air that we can breathe. So things like that might confuse them. Gas giants, many of them think that you could just fly through a gas giant, that it's a big cloud. So the difference between what a nebula and a gas giant is very confused. And actual scales. So exactly, it's important to know your audience. Very, very good. And what they've been taught, and ask have you watched my slides already? Is that where you're getting this from? It's important to get help. Very, very good. Ask the teacher, get input from an educator, from a parent. You've been reading my mind here. And starting with something from a popular, from science fiction movie or a Marvel is great. That's wonderful, because if it's something that they like and enjoy, that would absolutely be fun for them. Bye, Mike. Thank you for joining us for a bit. So getting their input, getting the input of an educator or a parent. If somebody's invited you to come do something, get their input, plan what you're going to do with them. They know the audience, they know the kids and what they know. So great points, very good points. So we have a plan now where we're going to do a few activities with you all and hear from you how this activity works well with kids and how you might modify it for different kids. So Sha'Rell, let's go ahead and let you start off here with our moon scale activity.
Right, so this is the interactive part of our presentation. And so if you would like to join us, we would like to ask you, we're gonna start off with the moon scale activity, and you are probably familiar with it. If not, it's quite all right. I'm gonna show you how it works. So if you will, would you please take a sheet of paper and a pencil pen, and I want you to draw a 2-inch diameter circle, and this is gonna represent the Earth. Go ahead and awesome, Miss Vivian, you are definitely on it. So I have my 2-inch circle here, and I want you to answer the question, how big should the moon be in comparison to your Earth? And while thinking about that, I want you to give me a small drawing. Yes. So compared to the 2-inch Earth that I have on my camera here, which would you say would represent the moon? Would it be A, B, C, D, or E? And I want you to put that in the chat box. Which circle represents the moon scale relative to the Earth? Thank you, Sean, for participating. Thank you, thank you. Awesome, Elise. All right, Marianne, thank you. Bill, Misty, you guys are awesome. Amber, thank you so much. And we're gonna shut this poll down in 5, 4, 3, 2, 1. Well, guess what? As an effective educator, I will not reveal the answer just yet. Next slide, please. Awesome, awesome. Okay, so that was the only slide, but I'm not going to reveal it just yet. Christine, you want to say some more about this before we move on, before the drum roll happens?
I think that in addition, I'm really curious as to how far apart people think they're going to be after you reveal how big it is.
Yes. Okay. So I'm going to remove my virtual background so everyone can see my drawings that I've made, or seen my, okay, awesome. So I have and excuse the scratch that's on my Earth, and I have my moon there. And excuse me for my pink fingernails. I have to be a little extra. Okay, so I have my moon here, and I have my Earth, and I want you to tell me how far away should they be? How far apart should they be? Is it here? Here? Just tell me, oh, thank you, Vivian, for giving me that visual. Okay, just tell me to keep going or not. What's that? What about here? Miles apart? What? Okay, so are you telling me that my moon is not even on my screen?
So
she has that pinky in the air.
Keep going. My question was inches, feet, or miles apart. So they're saying keep going. Sha'Rell, can you go ahead and turn sideways so that we can see one of these objects closer to the camera and one of them further apart?
Yeah, so let's do this.
So about that distance, folks, or closer or further? Christina says not on the screen. Kate says about 1 meter apart. Bill says feet apart. So if the Earth is right next to her camera, is the moon still in the same room? Is it by the wall?
I'm trying to get it in that corner, guys.
Okay.
Remember, I'm only 4'11".
So it is in the same room, and actually, right now, so Sha'Rell, you're holding your arms as far apart as they will go, right?
Yes, I am.
Yes, you are.
Well, I am now.
You are now. And Melanie, yeah, there's a video there. So the distance that Sha'Rell is holding them right now is, let's say it's about 5 feet. It is several feet. The accurate distance, Sha'Rell, go ahead and let them know what the correct answers are, both the size of the moon and the distance here.
Should I?
Yeah, I think we've made them wait long enough.
Okay, so our moon would actually be the B representation. Is that correct?
Yeah, it's a quarter of the width of the Earth, and it's really hard to tell from the picture, but C is about a third, B is about a quarter.
Yeah. So, and I think Mr. William put that in our chat box too. He reviewed it a long time ago.
The distance is about 2 arm widths. So about as far as, if you put one arm here and the other arm as far as it'll go back there, about that far apart. So we have questions for all of you, not just about the moon, but about this activity. What strategies did we use? What strategies did Sha'Rell use in this activity that could help to engage children? What ways might this activity engage children? And Carlos, you put down suspense. So the suspense can engage kids, finding out, the anticipation, making them imagine, and helping them visualize. Yes, helping them visualize. Did Sha'Rell give the kids a role in this? Did she just tell them what the answer was?
I think that, Christine, this was also welcome participation of others around them. So if they had a sibling, or even if they were the only child, they could have their pet to be an object, and then the distance between wherever their pet was and them lie, or they could get their favorite stuffed animal or something like that.
I really like that we had something to hold in our hands, that's really a nice, beyond just a visual, something tactile.
Sure.
So one of the things that we like about this virtually is that you can have the kids, and we've done it with Girl Scouts, have them have that piece of paper with the circles and have them cut out the circles and have them try to decide which one is right, and have them try to hold them and figure out how far apart. And for modifications, for if you're doing a little bit older, where they can start to make it a little bit more open-ended. So 8-year-old children, one of the modifications we've made is giving each child balloons when we're doing this in person, and asking them to pair up together. Doesn't work so well with younger children, needs to be about 8 years old at least, and have one of them blow up a balloon to be the Earth, and another one blow up the one to be the moon, and try to estimate how big or small to make it. And yes, have one of them hold the Earth balloon and have one of them hold the moon balloon, and start to estimate how far apart they should be. Or have teams estimate, and then let them know which team came the closest to being right. That competition's always fun. Any other questions or comments on this activity before we move on to the next one? Let's do another one. Let's do another one. Keep it moving. Keep it moving. So for this next activity, it's called Searching for Life, but it's got many different names here. And some of you might have seen this one before. For this one, we want you to pretend like you are children, and we're going to do an experiment. But part of this is describing characteristics for life, because if we're going to measure life and look for life on places like Mars, then how will we know if we've seen it? So the first question is, if you are children, what are some characteristics for life? I want you all to pretend like you're kids. It's a hard question for PhD, absolutely. So let's pretend like we're not PhDs. Let's pretend like we are 6 years old, 7-year-olds, 8 years old. What is something, how do you know if something is alive? What is something that's alive? What does it do? It eats, that's great. It moves, it breathes, it can breathe, absolutely. Motion is helpful. It grows, absolutely. And of course, we need to modify each of these, right? Because the wind makes things move, but they're not really alive. Computer viruses grow, but they're not really alive in a way. They, reproduction. So all of these things are great. Absolutely. It does something, breathes, moves, grows, reproduces, and it keeps doing it. It doesn't just do it for a few seconds. It keeps doing it, right? So based on that definition, we're going to do an experiment here. And in this experiment, we're going to be looking at 3 samples, and it passes gas. It expels things too. I'm going to be switching to another camera. So I'm going to turn off this camera and this microphone and switch to my other camera and my other microphone.
Carlos, I love that you mentioned how fun being a kid is, as being a true scientist and all that curiosity. I agree. I wish I could harness that every day in my own work. I probably never get anywhere, but I wouldn't ever answer an actual question, but I'd have so many of them.
Absolutely, absolutely. Okay, so here I have 3 samples, A, B, and C. And each of these, you can do this activity virtually with the kids, or you can have them do it in person. And you could have the kids measure and weigh each of these samples. Each of these samples, you could have them take a quick sniff with their chemical receptors and tell you what they smell. Right now, I don't smell much of anything from any of the 3, but you can show them each up close what the sample looks like. And so if life does something, the first thing life needs nutrition in order to do anything, right? So we're going to add a packet of sugar to each of these samples. One there, and one here, and one here. And another element that all life, as we know it here on Earth, needs, at least for the reproduction part, is water. So I have some nice warm water here. And I'm going to add some water and stir each sample. So I'm going to add some water, enough to cover sample A, and enough to cover sample B, and enough to cover sample C. Maybe a little bit more to cover it, a little bit more to cover it. And I'm going to stir each of them. And this one, you might have noticed, started fizzing a lot. So it's got quite a lot of nice bubbles on it that you might be able to see. And if I smell it, I smell mintiness. Sample B had a couple of bubbles, but not much else. I'm going to stir it a little bit more, let you take a little bit more of a look at it here. I see a few bubbles popping up. I smell something. It's a little hard to define right now. Reminds me of the kitchen though. And sample C, I'm going to stir it. I don't really see any. I see one bubble. I see 2 bubbles, a little bit of foam, not much else. So right now, based on your observations, does anyone want to give us a prediction? Which of these might have ingredients for life? Which of these might have been doing something like reproducing, like eating, growing, moving, breathing, passing gas? So San votes for A. Does anyone else vote for A or B or C? And if so, does anyone want to add any extra details? Bubbles could mean that it's breathing. So A has a lot of bubbles right now and B has some bubbles. Bubbles
I
could
think
show
it's
breathing.
first you smell. That's a good start. They smell like something. Did C smell like anything?
C doesn't smell like anything at all.
Hmm.
Nothing at all. So some of you have voted for some things. What we're going to do is we're going to go on past this activity to the next one, and then we're going to come back and see what this one is doing, okay? So we're going to table this one, let our experiment grow, continue, see what the results are in a few more minutes. So let's go ahead and switch back and move to the next
Speaking of
slide.
suspense, that's even longer than the last one. I want to know. Let's see. I
It
think,
has to do its thing.
yeah, that's very cool. I'm gonna take over again for the young kids, and this is really fun to do with almost any age, or if you have a mixture of ages, you can get up and get moving. I mean, you can do this on a webinar like this or in a meeting or something. It's great to do in person, is really lovely. Just orienting them on Earth and trying to figure out, okay, so there are many misconceptions at this very young age that you live in the Earth, or, because it looks flat around us. They have their receptors, their light receptors, and they see that a lot of everything around you looks flat. But then they've heard that we live on a globe, and how do they relate those two? So talking about us living on the outside of a globe, you can show on a globe where we live. And then talking about how the Earth moves. So there are a few different ways you can do this. And if you have a lot of time, it's great to get oriented on Earth and figure out day and night. A lot of that you can show, ask them what kind of activities they do when they wake up in the morning. What do they do at night? What are some nighttime activities, and what does it look like around them? So similarly, there's a whole video on how to do that on that bit.ly site. I just stuck it up here again. So you can check out how to do some really good questioning techniques and engagement techniques. But I'm going to go ahead and go to the next slide and do an Earth orbit. And I like to ask a question to get started. And this is one of those questions you can ask kids, but not adults. How old are you? And often they will say 6 or some young age like that. And I don't mind telling you that I'm 44 years old. And do you know what makes a year? Does anyone have any idea what makes a year? Christine, when you have a second to switch it to the next slide. Thank you. It's great to be able to introduce new vocabulary. They love learning cool new words at this age, which is really fun. And we're going to introduce some movement. And it's a real drag that I am the only one that can be seen, but nobody can see you. So you should do it too. Okay, so go to the next slide. Oh, Christine, I'm glad you're here too. Okay, hopefully you'll do this with me. To the next slide, we're going to introduce the idea of an orbit. So the definition of the year is one orbit of the Earth around the sun. So can you say orbit? You can say it and nobody's
Orbit.
Okay.
Let's all say it together. Orbit.
Exactly. So some simple concepts to get you going, that one orbit makes 1 year. So I am going to introduce my son here because it's Halloween. It's going to be a pumpkin. And I'm going to put it right here on the back of my chair. And I am going to do one orbit around this sun. I'm going to be the Earth, and this is going to be the sun. So can everybody, nobody can see you all. You can all just get up. It's good to get up anyway during the day, move around a little bit. It doesn't hurt one bit. Go ahead and do one orbit. I'm going to actually bring it with me because otherwise. Whoa! Now you have to be careful not to introduce misconceptions. We're only talking about one thing here. We're just talking about the orbit and how it moves around. So we're not talking about daily motion or anything like that. So stick to one concept at a time, I would say, is probably easiest. So one orbit around the sun, and especially for young kids, have them run around one orbit Oh, Sha'Rell's got revolution. I love that word. Revolution is another word for orbit. We revolve around the sun. So good bringing that up. I appreciate that. So if everyone wants to, and this is also another way, we were talking earlier about ways to get the energy up with a group of children. Especially with young kids, I'm not going to do it because that's 44 orbits for me. But if you want to run around your chair as many times as you've been alive, every time you can say 1 orbit, 2 orbits, 3 orbits, and that gets that new word stuck in your head. You can even say 1 revolution and get a new vocabulary word in there. So that's one way to get them up and running around. If you go to the next slide, another thought is you can introduce seasons here because years are split up into 4 seasons, right? We've got winter, spring, summer, and fall. Does anybody know what season we're in right now? Not actually what's shown on this. Fall. Yes, Sean and William, we are in fall. How do we know it's fall? What are some of our clues around us that tell us that it's fall? So if you're on a video like this, they can raise their hand, they can shout it out. For at least the leaves are changing. And Jordan, yes, having the leaves change color is one of my favorite indications of fall. For us in California, we just got our first rain yesterday, which means it's officially fall. Sean looks at the calendar. That is a very good way to tell. Oh yes, Christine noticed that children will tell you it's fall because school has started. Right, that's what you do. Isn't there baseball in the fall? I'm not a big baseball fan, but I think we just finished that season, right? Maybe that's summer. What do I know? You can ask them about sports and weather, and you can try for different seasons, and you can have them act it out. So, okay, does anybody know about baseball? Oh, Williams has shorter days. Baseball playoffs, right? Oh yeah, that's just us that fell out of it. San Francisco didn't make it. Okay, I will not start any revolutions here. So you could practice throwing a baseball, right? So it's fall, baseball is happening. What is you can keep going on with that. What are things that you do in the winter? And, you know, depending on where you live, maybe you go snowshoeing, or maybe you build snowmen, or maybe you put on your rain jacket if you live in California. So things that they do during each season, talking about how it changes. And then it just goes around and starts all over again. Does anybody know what season comes after winter? Oh yeah, William, you got to find your sweater. You can put your sweater on in the winter. Yes, getting them to do some predictions. Excellent prediction, Sean. Spring comes after winter. That's wonderful. And talking about kind of what you do in each season, and how then it starts all over again as a cycle. Get them noticing these cycles, because often these are concepts that they have not put together. They've certainly heard of some of the seasons, they've heard of the year, but kind of seeing how these all fit together. You'll often find what they call around 5 or 6 years old, islands of expertise. It's really interesting. So you will find kids who will know every single possible detail about the planets, and they have all the numbers and how many can fit in what. I hope you have found some of those kids around. And but the problem that they've done studies that show that they don't actually have the framework to fit those things together. So here we're just going to give them some of the framework at a young age so that they kind of understand how these all fit together. Okay, so one last thing I like to leave them with is, what would you imagine you will be doing in 5 orbits? So get them thinking about, 5 years from now, what is their life going to look like? Because that's exciting for kids. It's going to be completely different for these kids. And they like to imagine what it's like when they get older. So there you go. That's just a really brief introduction to some activities you can do with really young kids. This is, 3 to 7-ish. I would say that would work. Great.
Absolutely. Thank you, Vivian. And for those of you who are keeping your eye on the camera over there, you can see that it has changed. Any new predictions as to whether A, B, or C might have life based on our earlier discussion about what life does?
Whoa, that looks so different. I hadn't been keeping an eye. Thanks. That's so cool.
It looks very different now. You might notice that what observations can you make? What observations can you make about A, B, and C? You can't see it. Oh,
I'm going to unpin myself.
well, here we go. Continue, and let's tell that to spotlight that one for everyone.
There we go.
Ah, is it spotlighted? Can everybody see it now?
It is. It's pretty small, I think, but
Is it pretty small? You know what we're going to do? We're going to stop sharing then.
there you go.
So now, can you see it? And if you can see it, what are you seeing about the samples? Earlier, it was asserted that A might have life. A had some bubbles. But the most change has the most life, maybe. B is definitely foamy, Jordan. You're right. B is very, very foamy. And lots of bubbles. B was doing something and it kept doing it. It kept doing it. So A was a temporary reaction. A could have been life, but it was temporary. It didn't keep doing it. There's still a little bit of foam left there that will eventually dissipate. B has lots of bubbles, and eventually it's going to go over the glass. It's grown considerably. And if I were to smell them, I would tell you that A smells a little minty, but most of the smell is gone. And that B kind of smells like bread to me. Looks like it's digesting something. Good points, Grace and Sha'Rell. Yes. And then C still hasn't done anything. So B would be a good observation there, that B looks like it's doing something and might have evidence of life, maybe. It did something and it kept doing it. It's growing. B is growing. So B happens to have yeast in it, which is a form of life. And we've got just a few minutes left. We're almost done. What sorts of strategies did we use with these activities that might be able to engage kids? With the samples here, with the kinesthetic activity that Vivian was talking about for the year, and her discussions about what happens in different seasons, what strategies were used?
Well, I just want to point out that I definitely use, like with the Searching for Life activity, we used household ingredients and things that was familiar: water, sand, sugar. So I like the fact that we use household materials, and typically that they would be able to repeat this activity if they desired to.
So, but yeah, familiar things that are familiar to kids. And yes, the comparisons, we make observations. They got to actually see something, and they got to say something. They got to do something. They got to share what they knew. They got to connect it to familiar objects, to familiar activities, whether it be baseball and school or what have you, and they got to move. So we were trying to incorporate some of those ideas of motion, some of those ideas of making observations, of sharing what they know. And you could always make changes. You could have them make additional measurements, or invite them to ask questions, invite them to suggest ways that they might want to make measurements, invite them to suggest changes that they might want to make to these activities. We have a poll for you all before we are done, because we are just about done. And in the meanwhile, if any of you have questions or suggestions or ideas that you would like to share with us, we would love to hear your ideas, your questions. Carlos, the pandemic taught us to be able to adapt to our home as a laboratory. Yes, absolutely. Do science with those homemade materials. Does anyone else with us have any questions or comments to share?
Carlos, I have Coke and Mentos. You can't see them behind me, waiting for this afternoon. I'm so excited. Speaking of science in your home.
Misty, thank you for joining us. Everyone, thank you for joining us. This is recorded. The recording will be available online. You're welcome to reach out to any of us for more information and ideas. There's a survey that'll pop up when you leave. We'd love to hear your thoughts about today and thoughts about what you'd like us to do in the future. Oh, that's awesome. That's so wonderful to hear. Thank you so much. Doing it for 40 years and you learn something new. That's wonderful. I think every time I meet with these lovely ladies, I learn something new from them. So, and we learn something new from all of you as well. So thank you all so much for joining us and for participating. I'm going to give you 5 more seconds to finish answering the poll questions. 5 seconds, 4, 3, 2, and 1. And y'all have a wonderful day. We'll see you again in a month or 2. Maria joined us from Brazil. So glad you joined us. Thank you everyone who joined us, whether it was from just down the street or from around the world. Have a great day.
Bye. Thanks, Christine and Sha'Rell. That was really fun.
Thank you so
I
much, Vivian, for
agree.
your time. We really appreciate your time and your expertise. That was awesome.